In today's video, we are going to learn about the method called substitution or u-substitution. And this method helps us find the antiderivative of a bit more complicated looking functions. Okay, let's start with an example. So let's say that we have antiderivative of x plus 4 to the fifth dx. Okay, so antiderivative of x plus 4 to the fifth. Now this is something that we have not learned before. This is new. But if you're familiar with polynomials, you can see that there is a way, and that we can transform this into a polynomial by expanding this binomial. But that wouldn't be efficient. That will take time, and if we can find another method that is efficient enough, then let's go for it. Okay, and luckily for us, there is indeed a method. It's the method of substitution. Okay, so what we're gonna do here is we're gonna substitute u with x plus 4. Okay, so you can think of this as like a reverse chain rule. Okay, it's not even a reverse chain rule, just the process of like substitution. Okay, so we're gonna make a substitution. So let's make that equal to u. And so since we made a variable substitution, we're gonna also have to do something about this. So since our variable is now u, then we cannot apply dx anymore. So the dx has to become a du, right? It's not that easy. You cannot just like replace dx with du. There has to be a process. Okay, and so to do that, we are going to find the derivative of u. Okay, so that will be du over dx. Okay, so derivative of u with respect to x is equal to 1. Or, and I'll use another color here, or du is equal to dx, right? So that means this. Okay, so now we are settled. We're done with the setting up the substitution. Now we're gonna do the substitution itself. Okay, so that will be antiderivative of, now instead of writing x plus 4, I'm gonna write u, because x plus 4 is equal to u. The 5's gonna stay, and the dx becomes du, because du is equal to dx based on the substitution. Okay, and if you look at this antiderivative, this is something that we have learned before, right? We know how to find the antiderivative of that. So that'll give us u to the power of 5 plus 1, which is 6, over 6 plus c. That's the antiderivative. And now we have to substitute back the value of u, which is x plus 4. So that will be x plus 4. That's u over 6 plus c. And that is the answer. That's the antiderivative of x plus 4 to the fifth. Okay, let's have another example. antiderivative of x to the fifth plus 2 to the power of 9 times 5x to the fourth dx. Okay, so it's a little bit of complicated function. The function is this. Clearly, we have not learned how to find the antiderivative of that kind of function. So maybe a substitution will help. And the way that you recognize how you can use substitution is by looking at factors. Okay, looking at the factors that are in your function. Here you have a factor of x to the fifth plus 2, and then you have a factor of 5 times x to the fourth. Now the thing is that if we find the derivative of x to the fifth plus 2, what you'll get is 5x to the fourth. And that is not a coincidence. We literally set it up. We set this function up so that we can use u-substitution, okay? So here's how we will do it. We're going to take this, we're going to substitute that with u, and then we're going to find the derivative of u. So du over dx is equal to 5x to the fourth. Or du is equal to 5x to the fourth dx. Okay? So again, u is x to the fifth plus 2. Du over dx is 5x to the fourth, or du is 5x to the fourth dx. So we're done setting up the substitution. Now we're gonna substitute. Okay? So this is equal to antiderivative. The x to the fifth plus 2 becomes u. Okay. The 9 will stay. And then you multiply that with 5x to the fourth dx. But then what is 5x to the fourth dx? Well, 5x to the fourth dx is du. So we can just write du here. Okay, so what happened there is that we turned this somewhat complicated antiderivative into a very simple antiderivative by using substitution. Okay, so let's see. Well, we know how to find the antiderivative of that. That will be u to the power of 10 over 10 plus c. Okay, let's use color blue. Okay, u to the power of 10 over 10 plus c. And then we're gonna substitute back our u. Our u is x to the fifth plus 2 to the power of 10 over 10 plus c. And that is our final answer. Okay, let's have another one. So antiderivative of z squared over the square root of 1 plus z cubed dz. Our variable here is z. Okay, so let's see if we can find a substitution here. Well, if you look at this expression right here, that's 1 plus z cubed, and if you find the derivative of that, that gives you 3z squared. So we don't have a 3 here, but we have a z squared, so that gives us a clue that we can use a substitution here. Okay, so let's set up the substitution. So let's make u equal to 1 plus z cubed. Okay, and then we're gonna differentiate u with respect to z. So du over dz is 3z squared, or du is equal to 3z squared dz. And since we don't have a 3 here, okay, we don't have a 3 there, what we're gonna do is we're gonna divide this by 3, so that finally we have du over 3 equals z squared dz. Okay, all right, now so let's rewrite this as antiderivative of 1 over the square root of 1 plus z cubed times, I'm gonna put the z squared here and then the dz here, so they're the same thing because we're multiplying basically. Okay, so that becomes, I'm gonna use the substitution now, so that's 1 over the square root of 1 plus z cubed, which is u. So I'm gonna put u here and then multiplied by z squared dz. Well, z squared dz is du over 3. So let's make that substitution. So that's du over 3. So now our antiderivative becomes 1 over 3 square root of u. I'm gonna use blue for you. Okay, and then du. So what I did was I just multiplied this 3 with square root of u, because that's how you multiply fractions. Okay, and then since we have a fraction here, we basically have a 1/3, so you're gonna put it outside. So that's 1/3 antiderivative of 1 over square root of u. Square root of u is u to the 1/2 du, which again can be written as 1/3 antiderivative of u to the power of -1/2. We're putting it in the numerator, du. Okay, now we basically know how to find the antiderivative of u to the power of -1/2. So 1/3, then antiderivative of that is u to the power of -1/2. Let's use the blue color here. So -1/2 plus 1 divided by -1/2 plus 1 plus c sub 0, because we're not done yet. Okay, let's continue the solution here. So that will give us 1/3, and then we have u, let's use blue, u to the power of 1/2, because -1/2 plus 1 is 1/2. So 1/2 over 1/2 plus c sub 0, which gives us so 1/3 times, so the 1/2 in the denominator, when you divide by fractions, you multiply by the reciprocal, so then that will give you 2 u to the 1/2 plus c sub o, and then this is where we would distribute the 1/3. So this gives us 2/3 u to the 1/2. Now u to the 1/2 is just square root of u, then 1/3 times constant c sub o is just c, and then finally we're gonna reverse the substitution. So this will be 2/3 times the square root of u, which is 1 plus z cubed, and then plus c. So this is our final answer.